All right, today we're jumping into a cosmic detective story. This is a real-life mystery that ends with the Hubble Space Telescope staring into this far-off galaxy and finding an absolute monster hiding in its heart. So for decades, almost a whole century really, astronomers were just stumped by this one galaxy, M87. See, from its very core, it was blasting this insane jet of superheated gas thousands of light years out into space. You gotta imagine it, right? It's like a cosmic cannon with unbelievable power. And that led to the big question: what in the universe could possibly be powerful enough to create it?
And get this wasn't some new puzzle. We're talking way back, as early as 1917, scientists were pointing out this mysterious super bright light right at the center of M87. They knew something was there, something powerful enough to launch that massive jet, and for decades, that's all they had. The mystery just got bigger and bigger.
Now, to explain an engine like that, the usual suspects just weren't cutting it. Ideas about giant stars or maybe super dense star clusters, they just didn't have the juice. The answer had to be something way more extreme. So astronomers started looking at a really radical idea, one that came straight from Albert Einstein's theory of relativity. An idea that describes something that could, well, literally break the rules of space and time.
And what was that prime suspect? An object that had been predicted for a long time, but had never actually been proven to exist. A black hole. For decades, it was just this ghost in the math, this curiosity on paper. But then, as astronomers kept finding more and more of these incredibly violent things happening all over the cosmos, this theoretical monster started to look like the #1 culprit.
And this idea, it had been kicking around for centuries. It goes all the way back to the 1700s with this concept of dark stars. Stars so dense that not even light could escape them. Fast forward to 1915, and Einstein's theory of general relativity gives it a real scientific backbone. Just a year later, it gets put into mathematical form. But it took all the way until 1967 for it to get the cool name we all know today. So yeah, it was a long journey from just a wild idea to something we could actually go look for.
So what exactly is a black hole? Well, here's the tricky part. You can't actually see one directly. By definition, light can't escape it. So you have to hunt for it by looking at the chaos it creates around it. The goal was to find an object so unbelievably massive and crammed into such a tiny space that its gravity creates this point of no return, a cosmic prison where once you're in, nothing, not even light itself, is getting out.
But to prove this theory, you needed a seriously powerful eye in the sky, and that's where the Hubble Space Telescope comes in. It had just gotten this crucial repair mission in 1993, the one that fixed its vision and made it crystal clear. So with its new eyes, Hubble was aimed right at M87, ready to finally hunt down the evidence that had slipped through everyone's fingers for decades. And boy, did Hubble deliver. In 1994, it sent back an image that just blew the minds of the entire astronomy community. Right there, at the very core of the galaxy, was something they did not expect to see so clearly. This spiral-shaped disk of hot gas, just pinwheeling around, swirling violently like water going down a drain. This was the smoking gun they were looking for.
See, this disk wasn't just some pretty picture. It held the key to the whole mystery. Think of it like a cosmic speedometer. If you could just measure how fast that gas was whipping around, you could figure out the mass of the invisible thing in the middle. You could finally weigh it and crack this case once and for all.
So, how'd they do that? Well, they use this really cool trick with light and motion. It's kind of like how an ambulance siren sounds higher pitched when it's coming at you, and then lower as it drives away, right? Light does the exact same thing. So, the light from the gas that's rushing towards us gets squished, and it looks bluer. And the light from the gas speeding away from us gets stretched out, and it looks redder. So, by measuring the blue shift on one side of that disk and the red shift on the other, Hubble was able to clock the speed of that gas. And the number they got was just staggering, 1.2 million miles per hour.
I mean, just think about that. To make something move that fast, the object at the center had to have a gravitational pull that was completely off the charts, unlike anything we had ever measured before.
And this is where it all clicks into place. It's basic physics, really. Just like we can figure out the mass of our sun by looking at how fast the Earth orbits it, astronomers use the insane speed of that gas disk to calculate the mass of the thing it was orbiting. And the numbers they got back were crystal clear. The object had to be unbelievably massive and squeezed into an impossibly small space.
So, with the speed measured and the math all done, the verdict was in. The mystery that had been bugging scientists for decades. What was the engine behind Galaxy M87? It was finally solved. The calculations pointed to one thing. The object at the center had the mass of, wait for it, 3 billion of our suns. 3 billion. And all of that mind-boggling mass was crammed into a space no bigger than our own solar system. And let me tell you, there's only one thing in the entire universe that fits a description like that.
You know, the lead scientist on this, Dr. Holland Ford, he put it perfectly. He said the evidence was so overwhelming that calling it a supermassive black hole was actually the conservative explanation. Think about that for a second. What he meant was any other theory you could come up with would have to be even crazier and more bizarre to fit what they were seeing. The black hole was actually the simplest answer on the table.
And just like that, a theory that was born from pure math almost 80 years before was finally proven with hard evidence. This was so much bigger than just one galaxy. It was a huge, stunning win for Einstein's general theory of relativity. It proved that, yeah, gravity really can get powerful enough to bend and warp the very fabric of space-time itself. This discovery was a total game changer. It didn't just solve one mystery, it gave scientists the tools and really the confidence to go hunting for these monsters all across the universe. And that leaves us with a pretty tantalizing question to chew on, doesn't it? If a black hole with a mass of 3 billion suns was one of the first major ones we confirmed, what else have we found since then? What other monsters are lurking out there in the dark?